Today's lesson will be on the concept of relative atomic mass. All of the elements on the periodic table make up everything there is in this world. The periodic table consists of most of the known elements, about 109 of them, and it was developed by a Russian man called Dmitry Mendeleev around 1860. And you can see his picture there. And he managed to put all the elements in order of the weight without any sophisticated equipment, which was quite an achievement for the 1860s. So this is Mendeleev's first periodic table, and you can see here that there are a number of elements that he did not know existed yet, and they're the ones in the pink background. However, he did manage to organize the elements of the time in corresponding weights, and made some good predictions around groups and around periods. And the power of the periodic table developed by Mendeleev was there were certain elements like scandium and gallium which had not been discovered, yet he predicted they would be found and have a certain molecular weight. So, what is a relative atomic mass number, which is the name of the topic today? Well, all atoms were measured against carbon, because carbon is the most common element on Earth. And the carbon atom was assigned the atomic mass of 12. Okay, so if you look at the periodic table, the number 12, which you see, the nucleon number, says that each carbon atom has a mass of exactly 12 atomic mass units. It also tells us the number of protons and neutrons. 6 protons and 6 neutrons. We know it's 6 neutrons because 12 minus the proton number gives the number of neutrons, which is 6. So we say that the relative atomic mass of carbon is 12. So, what about other elements? Well, hydrogen has a relative mass of 1 compared to carbon. So this means that hydrogen relative to carbon is 12 times lighter. It takes the mass of 12 hydrogen atoms to make up the mass of 1 carbon atom. So we say the relative atomic mass, the AR, is 1 for hydrogen. For oxygen, the relative mass is 16 compared to carbon. So that means that an atom of oxygen is going to be 16 over 12 times larger than that of carbon, which if you do it out in your head, it's just simply 1 1/3 times heavier than an atom of carbon. So we say that the relative atomic mass of oxygen is 16. All of the relative atomic masses for all of the atoms are found on the periodic table that you have. And there it is there. So for example, the relative atomic mass of iodine, well, it's probably better to do it in black to see it, of iodine is 126.9. Or say chlorine, because that's a very good example, is 35.45. And the reason why it's not a whole number, say like sulfur with 32, is because chlorine exists in isotopes, which we've already learnt about earlier in the course. So the number of neutrons is different in different atoms of chlorine. And the ratio of these isotopes gives the overall relative atomic mass of 35.5. So we can use the atomic mass and the periodic table to find the molecular mass of molecules. And this is simply done by adding the atomic masses of all the numbers of atoms in a compound, which we're going to do an example of in the next slide. It's important to note though that in terms of atomic mass and molecular mass, there is something also called the molar mass, or molar masses, and that's got a capital M. There's no, what would you call it? There's no subscript. Okay, there's no subscript of R, these guys here. Okay, and the molar mass is the mass of 1 mole of that substance. and has units of grams per mole. And we'll learn more about the mole in the next lesson if you're a bit confused about that. So let's go through a very quick example of how to use or how to calculate the molecular mass from the periodic table and relative atomic masses. So the relative atomic mass and the relative molecular mass are very similar concepts. So the relative atomic mass, AR, is the relative atomic mass and is used for single atoms. So for example, calcium, nitrogen, and oxygen, etc. And this is dimensionless, meaning it has no units. So for example, the relative atomic mass of calcium from the periodic table is going to be 40. The relative molecular mass, on the other hand, is the relative molecular mass of a substance or compound, and it's going to be the sum of all the relative atomic mass values of the atoms in that substance. So for example, the atomic mass of hydrogen is 1, so the molecular mass of molecular hydrogen is going to be 1 plus 1, or 2. So, what's the relative molecular mass of water, H2O? Pause the video now and come back once you've worked it out. So, welcome back. So hopefully you get the same answer as I do. The answer I got was 18. Now how did I get that? Well, it's going to be H2O is the formula, so there's going to be 2 hydrogens and 1 oxygen. So you've got 2 hydrogens, so you multiply the relative atomic mass of hydrogen, which is 1 by 2, to give 2, and you multiply the relative atomic mass of oxygen by 1, because you only got 1 atom of oxygen in water, which is 16, and the sum is going to be 16 plus 2, or 18. So one final example is, what is the relative molecular mass of sulfuric acid, H2SO4? So pause the video now and let's hopefully come back with the right answer. Okay, so the answer I got was, well, let's just do the calculations first. So you've got 2 hydrogens, so it's going to be 2 times 1, because 1 is the relative atomic mass of hydrogen. That gives us 2. You've got 1 times the relative atomic mass of sulfur, which is 32, and this time 4 times the relative atomic mass of oxygen, which is going to be 64. So if you add those numbers together, 64 plus 32 plus 2, you get the answer, which is 98. So hopefully you got that correct. If you didn't, it's time to get back into your textbook, have a look over your notes, and see where you went wrong so you can improve.